Now we'll discuss question of linear algebra which came in part B of IIT Jam exam 2017. The question states that for any two x and y matrices of order n cross n, we have to choose the correct statements. The statement A said, if P inverse xp is diagonal for some real invertible matrix P, P inverse xp is diagonal. It goes by the definition of diagonalizability. It simply means that x is diagonalizable, and by the definition of diagonalizability we can easily state that there will definitely exist a basis for Rn consisting of eigenvectors. So by the definition of diagonalizability, the statement A is true. Now the second option states that if x is diagonal with distinct diagonal entries and xy equal to yx, means the matrices x and y commute, then y is also diagonal. Let us suppose x to be m0 0 n, a diagonal matrix, and m not equal to n. Let y be any arbitrary matrix a, b, c, d, and it is given that xy equal to yx. It will imply m0 equal to now we will compare these two matrices term by term, the first entry being am, the second entry being when we compare these two matrices, the first entry of this matrix and the first entry of these matrices are same, and similarly the fourth and the fourth entries are same. When we compare the second entry, it is MB and BN. If MB is equal to BN, it will simply means B into M minus N is 0. Hence either B is 0 or M minus N is 0. But if M minus N is 0, it will imply M is equal to N, which is a contradiction since we took them as different. Hence B has to be 0. Similarly, when we compare the third quantities of this and this, NC equal to CM, and since M and N are not equal, C has to be 0. Hence in this matrix Y, B and C both have to be 0. Hence Y also becomes a diagonal matrix. Hence statement B is true. The statement C says that if x square is diagonal, then x is also diagonal. Either we prove this statement, or if we find a counter example of x which is non-diagonal and x square which is diagonal, then C option will be false. Let x be 1, minus 1, 0, 1. X is a non-diagonal matrix and x square will be 1, 0, which is equal to 1, 0, 0 and 1. X being non-diagonal but x square is a diagonal matrix, hence the statement C is false. Option D states that if x is any diagonal matrix and xy equal to yx and x commutes with every matrix, then x has to be some lambda times I, that is x has to be a scalar matrix. Now let us suppose x to be any diagonal matrix and y to be any matrix A, B, C, D. If x commutes with y, it will imply AM, and the second term will be MB, NC, ND equal to AM, CM, BN and D. This is XY and this matrix is YX. On comparing the two matrices term by term, we can easily state that this first term and this first terms are same, the second term of the fourth term of this and the fourth term of this are same. On comparing the second terms, we will have mb equal to bn, which will imply mb minus b times n minus m is 0, and hence either b is 0 or m is equal to n. From the third term, we can state that nc equal to cm implies n minus m, c equal to 0, either c is 0 or m is equal to n. But if we restrict either of b equal to 0 or c equal to 0, we will restrict the entries in Y, but the result states that for all Y matrices. Hence, we cannot restrict b equal to 0 and c equal to 0. Hence, m has to be equal to n. So, our matrix S will become m times 0, 0, m, which is definitely m times I. Hence, result D is also true. So, our answer will be A, B and D. Thank you.